All right, Algebra 2. Going into 5, 6, fundamental theorem of algebra. Essential question, what is it? What is the fundamental theorem of algebra? Well, what it says by definition is, if p of x is a polynomial of degree n greater than or equal to 1, it's linear, quadratic, whatever, then p of x equal to 0 has exactly n roots, including all multiple and complex roots. So when you take everything that we've been talking about here, rational roots, irrational roots, Descartes' sign, all that kind of stuff, this basically tells you that whatever the degree of your polynomial is, that's how many roots you're going to have. Okay? You know, second degree, we did quadratics, we got 2 roots. Sometimes there's a multiplicity of the same number, but there's two, you know, it's 2 of the same number. We did the x cubes and we were getting 3 roots and so on. Okay? So for example, what if p of x is a 5th degree here? X to the 5th minus x to the 4th minus 3x cubed plus 3x squared minus 4x plus 4 equals 0. That's a mouthful. Okay? How do you find the roots? Well, make sure it's in standard form set equal to 0, which we are. You've got p over q, so you can find roots that way to get it started because you're not going to factor that thing any other way. And then we can synthetic. Okay, kind of the same things we've been doing. We're just going to kind of back up this fact right here that you're going to get, in this case, we should get 5 roots. So I take my p's, my factors of my constant, 1 times 4 and 2 times 2. Factors of 1 are 1, so 1 goes into each of those. So those are the possible roots that I have. So I start out, I plug in 1, and what do you know? I get 0. So 1's a root. So just like we did in the last section, I'm going to do synthetic division. By putting 1 out here, there are my coefficients. Bring down the first term, multiply, put it here, add, multiply, put it here, and add, multiply, put it here, and add, so on. And I get no remainder, which I should, because I already know from the remainder theorem I'm going to get 0. So there's my constant, my x term, my x squared, my x to the 3rd, my x to the 4th. So there they are right there. Because 0x cubed and 0x, I'm not going to write them in there. Trinomial x to the 4th, we talked about this earlier. You can split that up as x squared and x squared. Factors of 4 that differ by 3, 4 and 1, 1 minus 4. So I get the 4 with the minus, the 1 with the plus. So x equal to 1. If you set it equal to 0, you're going to get x is 1. There's your first root, which we knew. X squared minus 4 equal to 0. Subtract or add the 4 over and square root both sides. This is a square root. Okay, so I get plus or minus 2. Subtract the 1 over, square root both sides. And remember, the square root of negative 1 is the same as I squared, so the square root of that would be plus or minus I. So my n was 5. I had a 5th degree polynomial, so I'm going to get 5 roots, and there they are. 1 plus or minus I and plus or minus 2. Okay? So it works there. Let's take a look at one more example. That example, we had to use p over q to find our roots. If you look at this example, it's problem 2 on page 342 in this section. They give us a graph. And from the graph, we see that the graph crosses the x at negative 3 and 3. So for the equation x to the 4th plus x cubed minus 7x squared minus 9x minus 18 equals 0, I've got a positive here to the 4th, so I know I'm going to go up, which this does. And you can look at the graph in there. Here's where it crosses. So I started with negative 3 since I already got a starting place, so I went right to the synthetic part of what I just listed out there on the last board. Did synthetic. Of course, I know I'm going to get 0 for my remainder. Then I took my 1, negative 2, negative 1, negative 6, and now I put 3 into it because I know 3 is another 0 in this case. I got to see that from the graph where it crossed the x-axis. So bring it down, multiply, add, go through that, no remainder. There's my constant, my x, and my x squared. There it is right there. So I got x plus 3. Remember, you got to change the sign when you put it in here. X minus 3, and then my x squared plus x plus 2. I can't factor that. I can solve for x here when I set it equal to 0. Subtract it over, add it over. Quadratic formula here. Negative b plus or minus b squared minus 4ac all over 2a. That's going to give me 1 minus 8, which is negative 7, which I make 7i squared. Then I take the square root of the I, and that's what I get. So in this case, I have 4th degree, so I'm going to get 4 roots. There they are. 1, 2, 3, and 4. Remember, that's plus or minus, so it means plus or minus. So it's my 4 roots. Okay? Fundamental theorem of algebra. Whatever the degree of my polynomial is, that's how many roots I should get. Okay? We'll look at more of this today in class. Have a good one. Bye.